Hi guys, I'm Kamlesh and welcome back to Edustart. Now, for the people who are coming for the very first time to my channel, please don't forget to subscribe my channel. Uh, and let me give a brief introduction of myself. I am Kamlesh and I work for Amazon. And today's session is a very interesting session where we cover the Titanic data and we look into what exactly the machine learning is all about. And let's have a quick recap of yesterday's session where we'll try to understand what exactly the machine learning and things like that. So these are the topics which we covered on the day before yesterday's class, and we'll check what exactly the data, how the data is collection, and how is the data is collected, and pre-processing and pre-process methods and things like that. Okay, and how what is data pre-processing, what is data pre-processing and data acquisition, hypothesis modeling, evaluation, deployment and optimization we have seen in the earlier class. And we also seen the what is the example, what is the distinguish between the traditional programming as well as machine learning. So machine learning is nothing but this machine learning is divided into two parts, whereas one is training and another one is testing. Where training means the training the algorithms, okay, and testing means training the algorithms and try to test on the testing phase, and actually we'll try to find it out what exactly the accuracy is all about by deploying the models. So that is the example. So we have already seen the steps and things like that. So, and we also seen how the deployment is going to take place, what where different sources and different fields where machine learning plays an important role, different fields where machine learning is used. Okay. And also we try to learn what exactly the supervised learning and the functions of the supervised learning, what how supervised learning uses. And also today also we'll try to work on a Titanic data where we try to examine what exactly how many number of survivors were there in that. So many of them we have seen the data of we have seen the movie of Titanic, I guess. So we can rehydrate and actually get to know how machine learning works over there. So that's what, and we also learn about what exactly the process of supervised learning. So what historical data, random, how the test and train data has been utilized, and machine learning and statistical model evaluation and things like that. Once again, we also get to know how the supervised learning works, like using the different models of linear regression, logistic regression, decision tree, random forest, and Navi based classifications. And also, we have understood what exactly the project life cycle of a data scientist. We also we also learned about defining a problem, identifying the desired outcome, determining whether the data is needed or not, evaluating the possible solutions, and measuring the effectiveness, and also making improvements and communicating whatever the project report, whatever the project report which is as a data scientist which we try to prepare, we have to communicate that. So that those are the major important roles of a data scientist. So let us understand what exactly the logistic regression is, and also we'll take an example of a Titanic data in logistic regression. And tomorrow in the next session we'll try to learn what exactly the linear regression is all about, and we try to work on on a project of linear regression, and then you'll get to know what exactly how it is behaving and things like that. Okay, so firstly, let us understand what exactly the logistic regression is all about. So, logistic regression is very similar to linear regression on the very first note. And when we use logistic regression, we use it when we have binary outcome. If an interested or the number is explanatory in the form of variables, we try to use a logistic regression for that outcome. The presence, absence of symptoms. So, example outcome of a logistic regression is in a binary form, whether it might be in the form of a 0 or 1 or a yes or no, or in the case of Titanic, how many people have survived, yes or no. So that is exactly what we trying to do. From the logistic regression model, we can also do is we can determine what exactly the explanatory variables can influence outcome. So, which means a variable has a highest or risk in production of outcome. That is, one has a disease and zero doesn't have the disease. So, zeros and ones plays an important role, where zero and one can be treated as a categorical variable. Zero and one can be treated as a categorical numerical variable. So, zeros and ones are used in this model, in the regression model. So, output generally will be in the terms of zero and one. From this equation of the logistic regression models, we can do is we can we can use an individual values of the exclamatory variables to evaluate he or she will have a particular outcome. So we can use an individual value and try to explain what are the variables to evaluate that whether what is exactly the particular outcome would be. So that is all about this linear regression, logistic regression. And if we start logistic regression model by creating a binary variable to present the outcome, that is dependent variable. So the dependent variable, one has the disease and zero doesn't have the disease. We take the probability p of an individual which has highest category coded category has a disease as a dependent variable. We use logistic transformation in the regression equation for the better understanding of what is a variable which is what is a logistic variable which is used in transforming the regression equation. In the next slide, we'll try to explain what exactly the natural logarithms and the codes of odds of diseases is taken care consideration, where L logic is equal to 1 minus 1 by p. So logistic regression, we have the formula like a plus b1 into x plus b plus x1 plus b into y1, followed by this explain the variables which actually estimation which are true or probable in nature with a particular set of values that has x disease. So p corresponding to the proportion with the disease, it has underlying binomial distribution true. Estimate logistic coefficient. So this is a little bit of theory which we have covered till now. So if you have any doubts in this thing, if you have any doubts in this regards, please comment in the comment box. I will respond as soon as possible. Okay. So what exactly is logistic regression in Python? From this lecture, we'll be working on the Titanic data Kaggle, which is a very famous set, and often students the very use this as a learning tool in the first stage of machine learning. So we'll be able to trying to predict a classification survival or disease, that means dead. So let us begin our understanding of implementing logistic regression in the Python for classification. Okay, we'll use a semi-cleaned version of the Titanic data. If you use the data set directly on the Kaggle, you need to do some cleaning. It is not shown in this lecture notebook. Okay, so this data I have taken from Kaggle. It's a very interesting data. In the very beginners, in the beginning stage of learning machine learning, people try to use work on logistic data, work on machine learning data, where where you can directly work on Kaggle, so that you may not require for a separate Python to copy paste and things like that. But it depends upon the individual person to person how much they are comfortable in working with them. So firstly, I'll explain what exactly importing libraries is, and how and why the libraries plays a very important role in it. So let us import some libraries. So importing libraries is say in earlier stages like Java, Oracle, C++. These were the languages where individual used to work on a code. They used to code and type these languages manually. Now, thanks to Python, where we can directly import certain libraries, whereas pandas for implementing what pandas for visualization. Okay, numpy for indexing, calculating, and converting normal two-dimension to three-dimensional map plot and seaborn, percentage of matplot. So these are the very interesting libraries where we can use data into visualization. And scikit-learn, another library, that plays a very important role in the Python, where we can directly convert the data into 70 and 30% of the data and things like that. Many more. What it's just a statistical toolbox from the different tools we can use from the toolbox from the different tools we can use depending upon the situation and whatever the type of work we are doing. I would like to give an example. Say, suppose, assume yourself as a carpenter and you have a toolbox. This toolbox is like pandas, numpy, matplot, and cplot. So the data is like a furniture. So whatever you want to work on the furniture, you have to what you have to import that, use cutting player and screwdriver and work on the furniture and try to make a output like a chair or table. So that exactly is all about importing the libraries. So let's start by the first data, CV data, by converting by transferring the train data CSV as a pandas data frame. So train is equal to pd dot read underscore CSV. That is a Titanic data. What we are giving is that Titanic data which we are trying to give over here. Okay. In the next, we are converting whatever the data of Excel sheet into CSV file, and now train dot head means if we try to run this code, we'll get the top highest amount of in ascending order. We'll try to get it. So passenger. So what are the data which we have? We have passengers survived, passengers list, passengers that in order, survived, whether they are survived or not, which is P class. P class is nothing but passengers class, like third class, second class, one, and the name and sex, age of male or female, age, what is this age limit. So um, SIB SP is a special sibling. So it's a special sibling, that nothing but the family with the siblings, and this is parents. PRC PHE is a parents with children. Okay, this is a column, and there's another column is a ticket, another column is a fare, another column is a cabin. So whatever the cabin which is available. NA is things which are not at all missing figure is treated as an NA, where data is not at all captured over there. And embarked is where the situation, it can be in a form of a categories. Suppose S class, C class, like how in train we have S bogie, C bogie, and things like that. So different features we have in this data, where our objective is to find out how many people have survived in this. So let us understand exploratory data analysis. Let us begin what exactly this exploratory data analysis. We will start by checking out the missing data. So what exactly the missing data can be used? We can use Seaborn library to simply create the heat map and see exactly where the data is missing and things like that. So to do that, we give a code that is train dot is null parenthesis. So what does this do is it converts the data of all the passengers, survive, P class, name, SX, age, sibling, special sibling, and parents with children, ticket, fare, cabin, and embark. It converts the data into false and true. Where true we can find, see, the true and age also true. So here the data is NA. Okay, not available. Here also false, true is not available. So by this we can able to find out the whether how much, what is the percentage of the missing data we can find in that. So in total they are about 891 rows which has been currently present. 891 rows into 12 columns, they are currently existing in here. So to do that, we'll convert that into heat map, where heat map is such a kind of a visualization where we can easily find it out and make a difference what exactly the features, the x-axis and y-axis features are, um, what null items are present in that. So so the code is goes like this. So s.sn, we have imported pandas as s.sn. So see, we have imported the cbond as s dot sns. So we try to apply the cbond for heat map like s dot sn cbond int dot heat map, whereas train dot is null. So whatever the train data is, it whatever the null items, take that, and y tickle labels is equal to 5. That means we don't need y axis. That's the reason we have given false. We need only x axis and for the consideration part. And comma c bar is equal to false. C bar is equal to false is that means the column bar, we don't need a column bar too. So map visualization is VIR DIEIS. It's in a string form. So that gives a better picture of what exactly the background color and things like that. So whatever the data which we got here, we can see that the age has a little bit of missing figure and the cabin has a lot of missing figure when compared to age. So what we can do is roughly 20% of the data age is missing in the over here, and a portion of age is missing, and a proportion of the age is missing like a small enough for the reasonable replacement with some form of imputation. Okay, looking at the cabin column, it looks like we are just missing too much of the data. To do something basic level, we probably drop later or change the feature, or else cabin feature known as 0 or 1. So depending upon that feature, we'll try to work on what best we can do. So S and S is a cbond dot style underscore net. So that is white grid, and SNS dot counter plot x is equal to survive dot data is equal to trend. So by this thing, we can easily get to know from this dot we can easily get to know what exactly the matplot is. And white grid is a background color, and x axis we have taken survived, and data is equal to trend. So this interesting part we have covered over here is how many people are survived. So survived is very less. It's approx 320, 330 would be, uh, the people who have deceased or dead, it's gonna be around 550 plus, 550 change. So this is the major advantage of a cbond library, where we can get accurate information about when and how much people have survived. We can easily get to know how many people have actually survived. So how many people have actually? Okay, continue. Let's continue. Okay. So s dot sn. So cbond library dot set at the rate style grid, and we have included s and s as a counter plot where x is equal to survive, and HUE, that is the inter part of sex, and dot train dot paddle patty is equal to ruby. So this is the format which we need. So the another part, we have given this thing to identify what exactly, whether it is a male or a female in this thing. So survived. So in this survived, how many male are survived and how many female, and in survived, how many are male and female, in death how many are male and female. So female have survived more than compared to male, as if we rehydrate from the movie, we get to know, we'll encounter that women and children were first person to move from that. So women and men were the first person to get out of the ship. So uh, and upper class also were given opportunity to move. So again, from this data, we try to visualize what exactly, how many people, which class of the people have tried to survive. So HU is equal to P class. That means the data train in the platter in the form of a in the form of a rainbow color. We need in the format rainbow format. That is color in form of rainbow color, which we want this thing to be visualized. So it's nothing but in this survived, this one is a first class, and this one is a second class, and this is a third class. So third class people in male has highest amount of death ratio in the death when compared to all, whereas in survived, the first class people have survived, first and second class a bit, and third class has been less. So high majority of the class one have survived in among all the three. So this is what the data is trying to tell, how many people have survived. So another, we are trying to create a disk plot, and we wanted to drop age. We want to check age and drop NA in age, and KD is nothing but it's a density formula. We'll discuss about that in the coming up sessions, where where we'll get to know what exactly the KDN is false, and colored and bins. What is the size amount it. So from this diagram we can easily represent that, if we take the class interval of 0 to 10, how many people have actually survived from 0 to n. So the highest maximum is around 20 to 25, 20, 25, 20, it's gonna be 26 or 24. So okay, and highest majority of the people age traveled is up to 20 and 30. It is also a normal distribution curve where majority of the data points are 68% of the data is lie upon 20 to 30, and the larger majority of the data 95% of the data lies between 10 to 50. So this is a normal distribution. In the earlier classes we have already discussed what exactly the normal distribution and standard distribution is all about, and outliers are the 70 and 80. So 80 and people have so this is what this Titanic data is trying to explain. So next, train age. So train age is equal to history bins, that is colored alpha is equal to 0.3. This is the size. So here have changed the bins. So would like to, if the people you can also do it. You can also do it and create in this format. So the reason I have worked on this and copied from my Kaggle note to directly to do is to save the time, and I can explain you in a better phenomena. So if you have any doubts in that, so um, uh, please feel free to text in the comment box. Okay, and if you take an example of a Titanic data, if you see the movie which was made by James Cameron in the year 90s, some 90s, I guess so. I don't know, I don't recognize the exact name year. So that is what. So let us come back to the session. Uh, so now we'll try to understand what exactly the siblings and all, what exactly the siblings and the train data, what exactly is talking all about. So matplot data dot axis dot subplot, whereas axis is equal to siblings. So what siblings is talking about, what SLP is a siblings amount. So highest amount, there were no sibling, and sibling 1 were about to approx 200, and siblings 2 was approx less than 50, around some 25 50 and things like that. So this graph easily explains about what exactly how many people of siblings are provided. So this is amount of presentation which we try to give. So this is a presentation which we give. So what exactly the train, what exactly the history, we'll try to example whatever the fare is. So we'll try to plot a histogram, and color green bins 40 and figure size is 8,4. So if we try to project this graph, we'll get to know what exactly the data is talking all about. That is some approx 400 to 500 and 50 and 60 and things like that. So this is the amount of graph which we're trying to work, and which I'm trying to explain. So next, data cleaning. So if you want to fill the missing data instead of just dropping and missing age row, the one to do by is filling the remaining age of a passenger. So however, it can be smarter about and checks the average age of a passenger class for this example. So for this example, we'll try to figure size is 12 and S and S, that is the seaborne. Block spot x is equal to p scale and y is equal to age. Train data is equal to train, and platter is equal to winter. So this is a box plat. So box plat of age, we are trying to convert. We have just wanted to find what exactly the average, of each individual class. So from this data we can try to explain that average data is lies between
for class 1 is approx 37. For class 2 it's approx so much, it's approx 30, 25 to 30. And for class 3 it's approx 25. Okay, that is the story of it. So this is a blocks plot where we can easily make it out what is the average mean of every each and individual class. So by that we can able to fill whatever the NA missing items, we can easily find out what exactly mean is. And the next slide we'll try to compute the function. Have written a function like def impute age column. Age is equal to column 1, p class is equal to column 1. If p is equal to null age, then p class is equal to 1 on the very first class, please return it 35. If p class is equal to 2, that is in second class, return it to 35, return as 2029. Else return 24. Else if not upon from all the three, else return age. If we try to apply that function and then try to and then try to look into the blocks plot, where you can easily ascertain the train age is equal to age at psd. Apply impute age is equal to access 1. Now let us check the heat map. So s and s heat map is equal to train dot is null. So y tickle label is equal to false, where c balls is equal to for and c map is equal to vids. So if we try to look in a map plot axis and subplot axis at a 0 and subplot axis at 1, then we can easily find it out that age was already fulfilled with the mean. So that's a great job. Now drop the columns and row and embark, that is a NA. So now if we try to check cabin access as 1 and true, if we try to drop cabin. So now we try to check whether the cabin has been dropped or not. If we try to do that, cabin has already ditched in. So converting, basically now the converting the categorical into the dummy variable. So why now let us understand what exactly the dummy variables are. So for the machine to understand exactly, machines will only understand what exactly in the form of a binary system. So code in the form of a code, they don't understand what is categorically. So our job role is to convert the categorical data into numerical, and then we try to ascertain what exactly the data is talking all about. So converting it into dummy variables plays a very important role in the data in data science. So as a data scientist, you should make a call about what is important and what are unimportant, and which to drop, when to drop, um, where to drop, whom to drop. So these are the important things which we should have knowledge about the business analytics, like what exactly our requirement is, what do we need, what is our desire from that. So converting the categorical data, we need what exactly the categoricals which are present in it. So from the data we can easily make over that from the data we can easily make over that whatever the classes are there, what are the pandas, score data frame, passengers and survived class name. So these all are in the form of an object and integer. So some of them are in float. So we'll try to convert what exactly the normal data, and we get to know, we can see that embarked is an object, sex is an object, and name is an object. So rest of the everything is in integer, and fare is in float. So what are the things which are in object, we try to convert it into dummy variables. So we'll try that, since such as pd dot get dummies train embarked comma drop underscore first is equal to true. So that is head statement. So so and head for drop first is equal to true means it drops one column. So there are three columns, right? If you drop one n minus one, if you do drop one column, it's implied meaning that if it is 0 0, see, if it is 0 0, that means the other column might be 1. So we'll try to remove one column and then try to work only on these two columns, and then we can able to get what exactly the dummy variables of embarked. Okay, so next, same with sex get dummy, train sex drop first is equal to true, and things like that, and embark. So get dummies and embarked the first true. So train drop six is embarked name access one in place of true. One second. So guys, I forgot to inform a very important topic in data cleaning. Here we try to fill whatever that column uh, in as a median average. We can also find we can also fill the data uh, if it is mean or mode. So that depending upon the situation, one should have knowledge about what exactly he wanted to fill. So that would be mean or median or mode. That as a data scientist you should take a call. So technically in the offices and things like that, we have 1 hour meeting before making up a call what exactly we want to make, whether what exactly we want to select, whether we want to go with a mean or a median or a mode. So depending upon all these parameters, then we try to decide. This was a very important topic, how I forgot to inform, so again reiterating it. So say suppose if it has been mean, if we try to calculate manually and then try to dump mean, what exactly the mean column is, and what exactly for P2 and what exactly for P3, also you can apply the mean and median and mode. Depending upon you have to make up and things to decide what exactly you wanted to show. So heat map, heat map and things like that we have all cleared, and vertical labels we don't know, we don't require what exactly the horizontal, what exactly the y-axis is, so we just require a-axis. So vertical labels is equal to false and bar is equal to false. We don't need a bar to investigate, and what is a map and map size. So this is all about so in this cap we have to just we need we have put in the code like train dot head just to inform what exactly how many people have survived this thing and things like that. So converting the categorical variable and categorical features. So get dummies, get trained, and things like that. So now if we continue the session, uh, to continue the session, so we have converted the sex variable into dummies into train, like sex dot drop very first is true, and also the embarked if we try to convert, and we'll try to drop the sex embarked name access is equal to 1 in place true. So we are dropping this thing because we already created dummy variable for that. So drop these columns. Train dot head will get to know what are passengers survived, class, age, siblings, patch and fare. Okay, so will now already we have removed that. Now we try to concatenate what exactly the train and embark and access. If we try to concatenate that, and this will try to and if we try to check, that's going to display like passenger survived, class, age, sibling, everything, and male is 0.111. If it is 0 means it's a female. So q, s, and this thing, things like that. So now this part is all this part will try to understand what exactly the logistic regression model and what exactly building and training and split test. So uh, train dot now we have to understand what exactly train the data into split, train the test data and split. One second guys, I'm getting a call, 1 minute. So now let us understand what exactly the how to build a logistic regression model. So till now we have covered what is machine learning and what exactly logistic regression is all about. When to use logistic regression, why to use logistic regression, and what exactly the output is gonna be, whether it is dependent or independent. And we try to do future scaling, future engineering before we continue the data. We try to, and what we have done is we try to build a logistic regression. What we have done is till now we have understood, we have cleaned the data, we have converted the data, we're handling data deployment. Now uh, now the actual concept comes around building a logistic regression model, where where our job is to understand what exactly logistic regression gonna fit. So here the data is 0 and 1, we'll try to build logistic regression. So firstly we have to drop um, try to drop survived. So training and split train and training and split data, now here it begins. So we have from the data we have tried to drop whatever the actual amount we have survived. So what is the actual amount we have survived, we try to drop it over here, and trained out head. So whatever the survival, it has been displayed in another column. Okay. So from the scikit-learn model, import train test split. So scikit-learn model is another import library where we can get to know where we can get to know what we can split and what we can cut. So I'm interested in transferring the distributing the data into 30 and 70 ratio. So we'll write this code as xtrain comma ytest comma ytrain comma ytest is equal to train test split dot train dot uh, train dot drop. Survived access is 1, where train that survived the test size is equal to 0 comma 3, random state is 1, 0.1. So here we can directly get to know what exactly is we are dividing the amount of train and test data. And from psychic metric, import accuracy score. Accuracy is equal to accuracy score is one which gonna describe what exactly the score you're gonna landing up. So my model is trying to predict what exact accuracy score is by test prediction. So my score is approx around 71.9. One second. I'll show you. I'll show you what exactly how the Kaggle looks at the end of the session. So guys, please stay tuned. And let me open what how Kaggle. Let me open another window how Kaggle Titanic data actually working in Kaggle. So I'll show how I worked in Kaggle. One second, okay? Yes, guys, I had opened, had checked my Kaggle score, and after this model lab, I'll complete. I'll show you what exactly how the Kaggles look like. So now from this accuracy score, from Y predict is upon 0.719, that is 70% that we are accurate about. And I have also worked how to improve. We have to do if we use XGBoost XGBoost and cross validation k-fold and things like that, then we can then our model can definitely it gonna improve, no doubt in that. So next, a prediction score. Prediction score is also 0111. This is a prediction score, and I would like to show another important thing is this is a medium app, guys. Medium. So this is a very interesting article where I'll keep on browsing all about. So based on the reading history, we need data science. Why data science is boring, buddy? It's not at all boring. Data science. So please feel interested. If you are interested, please do come and watch this thing. See entropy principle, casual guide, machine learning, programming, visualization, clustering. This is a topic which we're gonna cover next. So these are the blogs which most of the people who have data scientists keep on updating here. So please pay attention to it. So that's an important tip which I'm giving you. I follow and I try to learn what exactly data science is going on in the market. So this is a very important one. So please have a tap on this thing. Okay. And if we come back to the session, so we have predicted approx up to 71%, and we check we now evaluate now we can evaluate what exactly by using precision recall, F1 score, and classifying report. So in the earlier session we'll discuss what exactly the precision recall F1 score is used, and how to prepare a classification report. Okay. From psychic learn with import classifier report, and then we're trying to classify what exactly the precision is about 82% recall is up to 81 F1 score, and support is so not so bad. You might also want to explore other features like Titanic, CSV, some figures. Try grabbing the data like Mr. and Mrs. as the name as a future and capital letter. Is there any info you can get from the ticket and things like that? The data also you can once again try to get into. So if you want to improve your score, you can also do pre-processing to cabin score, where we have cabin we have dropped over there. But if you want to improve your score, that try to do pre-processing to the cabin score, where output also will get increased by this thing. So that's all for the machine learning Titanic. Congratulations, guys, you have learned what exactly the logistic regression and things like that is gonna work. Now logistic regression within the model, and let us understand now how this Titanic data look. So this is a Kaggle competition. So this is a Kaggle where you can participate in a number of competitions. I'll show you what are the competitions which are prevailing in the market right now. So these are the things like 3D YouTube 8 million video understanding the challenges. For that price is 25,000. Several cheat detection, the price is dollars 130, and teams are up to 139. So let us see what exactly this details is talking about. Steel building yet given, and okay, this is all about the information. So data computation means there is a computation and coding pixel file format. This is a sample data which is giving us information. We have to enroll is we have to sign in into this and try to understand what exactly this competition is all about. So read this all data and try to work on this with the prize money. If your output score is less than output score is more high amount of percentage, the p value is high, then you gonna get this as a reward. And this is a machine learning, this is a Titanic data which we already discussed. This is a competition, this is evaluation. So how do they evaluate, and these are the tutorials and frequently asked question. If you have any doubt, you can come here and you can give the support what exactly this Kaggle set about the competition. Just by clicking join competitions, you'll get into this. So this here are the rules and regulations where each and every individual will teach you what exactly the competition is gonna be and things like that. So uh, till that we have discussed what here till now we have discussed the topic like statistics, ML, machine learning, and machine learning, and what else we have covered? Hypothesis testing and statistics. So majority of the topics which we have covered, the only things which are left over is um, AI. In AI, we try to work on CNN and then CNN and then CNN will try to work, and rural networkings will try to work, and simple linear regression, clustering. So next session would be I would like to take go through on linear regression. Now, linear regression, there are three types of linear regressions like multiple linear regression, simple linear regression. Okay, we'll go through what exactly and how the linear regression looks like y is equal to mx plus c and things like that. Okay, and next topic is clustering. We also will also discuss what exactly the clustering is up to, and what exactly the clustering is up to. And third part, we'll discuss how what exactly the CNN and convolutional neural networking and rural networking, how it is differentiated, what is the code for it. So depending upon that code, we can visualize and communicate what exactly the things is all about. And then the next part is NLP and computer vision. So these are the part which we gonna discuss and let you know as soon as possible what exactly we can do. So that's all for the last important point is the resume questions which we like to discuss. So what are the resume questions which has been allocated? What are the important points like important questions and where the interviewer is gonna ask and how you guys should answer and things like that. These are the important roles which gonna play. So till that time, stay tuned for the more updates. I would like to go through Titanic. Okay, let us assume what information they have given in this thing about the Titanic data. Prediction survival of the Titanic data. Okay, boarding pass. Okay, this is a beautiful picture in this blog. This is a disaster. This is the data set which they are trying to see. They have also imported the libraries and they have imported the scikit-learn model, logistic regression for random foresting. These are all the things. Linear regression and Gaussian algorithms are trying to working for that to get the data they have done. Then to get info, we'll get to know what exactly the information is all about. This is the passenger way. About 38% of the training data survived, and we also seen what exactly and how this data has been formed. So this is a cabin. So these are the amount of zeros. What missing data? Missing data cabin. It's in the total form of numbers which we have done in the form of a blocks block spot. Okay, and age and sex. They are converting the data. See, these are they have done using what normal distribution. Okay, and then they try to work what exactly the basic scales and things like that, what exactly the grid. So grid and embarked 5. Okay, this is another technique like by using seaborn they have worked on. So what exactly the male and female and using embarked seems to be what is a p class. We also use the same scenario and they also followed the same one. And this is a good referral article. I seriously suggest it's for a month. They're gonna charge you for 700 330 rupees, I guess. So this is it. And next you can find is data pre-processing, missing data, and we'll and importing. Okay, age, they have converted age. Another important topic is they have used a very complicated code. We have done it in a very similar and simple manner. So simple manner is a very good thing. What I suggest is it won't confuse you, it won't confuse others, and creating categories. And the code which I have explained, I would keep that in a description, in the description box. Please find that. Okay, so machine learning, they already used all the Gaussian linear support vector machine decision tree. Okay, here it is the model. So random forest model is they are getting 92%. Logistic regression they are getting 80%. So we got about around 70%, right? So I think they have pre-processed that one also. So random forest is a classifier goes on the first place, but let us check. So caseful validation. Caseful validation is also a very important thing. So how many things they can get to valid about random forest, they have explained in a wonderful scenario what exactly. So just as I suggest you to read this article through, and go through our ppts. So stay tuned. If you haven't subscribed to my channel yet, please do subscribe, and follow us on insta at Edustart now. So that's all for the day. Thank you guys, and good night. Have a nice day. Bye bye.